The first step of using automated business logic is to configure it, and you do that as follows. First, you locate your Hibernate configuration file, and you add this line to it. That's what sets us up as a Hibernate event listener. Secondly, you must have the business logic ear file added to your project. In this particular application, it's a web app, so I added it to the deployment assembly. And of course, you've got to add it to your libraries, like that. Build the logic classes. The default is here we have our POJOs, customer and item and so forth, and we just build a parallel package using the word logic as the suffix of the package name. You can change that, but that's not necessary. Because here we're just using the defaults, so these properties are commented out. So at that point, you're ready to build your logic and test it. So first, let's have a little background on the demo application itself. To do that, we'll use our generated documentation. We call this logic doc. You can read about that in the documentation, and a video there will show you how to run it. For our purposes, we'll just start it. It's an extension of JavaDoc. As you'll see, it's the same but different. So here's a use case, a documentation, and in it we see our data model. So this is the demo database. As customers, they have purchase orders, and purchase orders have line items. They're about products, so the world's most standard database. And a little bit more formally, here from the website is the 5 rules that it takes to implement our sample application. So let's go look at these in the implementation. So we have 2 rules on customer, the credit limit check and the balance derivation. So let's return back to our Eclipse. And here we've called up customer logic. Now let's make sure we're clear where that was. So under source, we put our data, our beans, our POJOs under the data package, and customer logic is here under the business logic package. And it's short. It's mostly comments, actually. And here's one rule. Here's the constraint. This is just Java. In this case, could have been Groovy code. And it does a check, and if this is bigger than this, then it issues a failure. So that's executable code. The sum, that's the second rule, does not look like executable code. In fact, it's actually all expressed in this annotation here. And this is all the system needs to do that, to enforce that logic. Notice that we call these business logic components. We customarily end them in the word logic. They are Java Groovy classes. The methods are the logic themselves, and they're identified by an annotation, which is described in your documentation. Okay, so we return. Our next rule is on purchase order. So that's very much the same. We look at purchase order logic. And we see that it's the sum of the line items amount. So what is line items? Line items is the child accessor in your POJO that goes from a purchase order to the line items of that purchase order. This is not actually in your sample yet. We are about to add that, so ignore that for the moment. And the last piece of logic is on line item, so we'll just look at that directly. Line item has two rules in it. One is to derive amount, which is price times quantity, and the other is to obtain the product price from the part, or the product. A parent copy is a special kind of logic that says if the price changes, don't update my, in this case, line item. So that's all the logic it takes to execute our sample application. Those are the 5 rules. Let's now look at the execution of that sample application. So now running the application, let's do our standard transaction where we just change a line item quantity. Now look at all this of what happened. The system is telling us, or the application is telling us, that we evaluated a formula because we changed the quantity, the price times the quantity changed. That updated a sum of the purchase order total. That in turn updated the purchase order, and that updated the customer's balance, which is what we would have seen here. Now, how did that happen? Let's ask that question. The key concept is what's called forward chaining. Order has rules that reference line item attributes, in particular the amount. If you change the line item amount, the business logic, remember we're signing up as a hibernate event, we analyze the change, we notice that the amount has changed, we then adjust the business engine logic takes the changed line item amount and uses it to adjust by a delta the order amount. The resultant order amount is also referenced by a customer rule, so that causes adjustments to the customer, and that checks the customer credit. We call this concept forward chaining, and this is the key to multi-table transactions. During some of the pre-releases, you need to make some repairs. Under Properties, make sure that the Java build path source includes test. Also, make sure that the JUnit4 library is included. If it's not, say add library. You also may have to fix the name of this class. Now we're ready to test our logic. What we'll do is we'll set a breakpoint here in our logic, and now we have choices to how to test it. We could test it under the Tomcat server by starting up in debug mode, but instead we've done what many architects and managers like to see, which is build some JUnit tests. In particular, we've built one called core tests. And core test does just what we want. It includes a test to change a line item quantity. So let's run core tests. Debug as JUnit test. Talk about all that logging in just a moment. And our breakpoint is now hit. We enter the debugger. And my actual logic class has those two instance variables we described. Very importantly, I can wrap text and see my entire POJO, the current values and the old values. So you see the amount total changing per the line item adjustment of it. So that's the debug information. I can do my usual debugging things where I can step through and see if my logic takes the wrong course. Also, this is the logic trace. You can turn this off, of course, and this is described extensively in the documentation, but it's important to notice that it'll tell you exactly what your updates were, how those forward chained, in this case through an adjustment, and every reporting. So this logs every single rule, also logs all the sequels, and for every logging event, it tells you the entire state of your POJO, including, for example, the old value in parentheses. So you can use this in conjunction with the debugger to quickly spot errors. Thanks very much.